We are live, Wendy's telling us. So thank you, folks, for joining us for today's live stream. We are very fortunate here to have an awesome partner. We were just mentioning they were also a big part of GTC that just wrapped up. Heavy.AI is with us. We have Brandon and Chris here. And we're also super fortunate to have not only Maddie joining us, because he's been working closely with his team, but also Dane, who's also been working closely with Dane. So welcome, Maddie and Dane.
Thank you.
And as I mentioned in the warm-up, Wendy is here, but she's not here. She's helping us with the engineering, but you won't see her today, unfortunately. She's a little under the weather, and her voice is very delicate right now, I'll say. But anyway, so we have a great show. Wendy hopefully feels better very soon, but we have a great show planned for today. Before we get into it, a couple of quick things. Next week, we're going to be talking with the Replicator team, talking about Omniverse Replicator. So that should be a great live stream. We'll put more details on Discord events later today. And you can also go to our Add Events calendar to see all our upcoming streams, including our streams that are only on Discord. And we also want to remind people that, as we just mentioned, GTC and Heavy.AI session, of course, wrapped up, but you can still see all that content. All you do is just register on the GTC site, NVIDIA.com/GTC. You can go to session catalog and you can check out all the great sessions. You can pause, fast forward as one of the benefits of watching it after the fact. So all those sessions are there, and there's a really great one from Damien on how to build an extension. So highly recommend for developers. Okay, but let's get the show started. So thank you both for joining us today.
Thanks for having us.
Yeah, so, super glad to be here.
First of all, you guys have a great company name, Heavy.AI. You have a great logo. I love it, all caps. Very bold. Actually, I'll let Maddie do the introduction. She's worked closely with you folks.
Yeah, so like Adamar was saying, is you guys had that big presentation at GTC. You were part of the keynote on the homepage for NVIDIA. You guys are a great partner because your technology leverages GPUs for a very fast processing of data, and enabling digital twins and analytics and GIS solutions. So that's all awesome, and you guys are going to give us a brief overview of how all of that works. And then the reason that I brought you guys on that I thought would be beneficial for our audience is you guys used your technology and developed a Kit application, an Omniverse application. And Kit is, for those that don't know, is our application development toolkit. You can leverage a lot of NVIDIA SDKs, USD, the Nucleus server, to develop custom applications. And so that's what they've done. And I thought it'd be great if we can get kind of a behind the scenes look at how that was built and learn from your guys' experience. So if you guys can introduce yourselves, starting with Brendan.
Hey, I'm Brendan Turner. I'm one of the senior engineers over at Heavy.AI. I've been there for a little over a year now.
Yep, and I'm Chris Motzenbach. I'm a software engineer at Heavy.AI, and basically a year too. I started like a couple weeks after Brendan. So.
Sweet. So yeah, tell us about Chris. If you can tell us about Heavy.AI and the company and what you guys do.
Sure. I have like just real quick. Can you guys everyone see my screen? Can everyone see me? Okay, perfect. So again, we're Heavy.AI, a super cool interactive data analytics platform company. Quote from this guy named Jensen. No, Jensen, we love him. He's been a huge supporter of us and the stuff we do. So just real quick, just a brief overview. At Heavy.AI, we've created a GPU-accelerated analytics platform taking advantage of the massive parallelization afforded by specifically NVIDIA GPUs. So our platform makes it possible to interactively analyze and visualize the largest geotemporal data sets instantly, even if they come from multiple sources and continually change. So when you kind of think about, we have a lot of products, a lot of things that enable this. Kind of the big one is we've built our own custom database. We have our own SQL language, and then we have a front end, visualization and analyzation software. So just real quick, so this is a quote from someone in the federal government, a client of ours, just showing with one solution, they were able to load a day of data, with another, a week of data. With ours, they were able to load a year of data with multiple data sets, and it was faster than others. So when we talk large, we're talking like hundreds of millions to billions of points of data, and that's going to really come into play with how we created this digital twin. So some of the industries, we have telecom, which obviously we're going to talk about today, then utilities, energy, and government, as mentioned. And so we have our clients do a lot of really, really cool things. Everything from genetic research to preventing forest fires, to green energy research. And then this is just kind of a little visualization of our front end tool. Just thought that was kind of cool. GIF, I will die in the hill. It's pronounced GIF. So
no, GIF, I disagree here.
And then real quick, we wanted to kind of introduce how we came about this and how we, came to Omniverse and, how this whole thing created. So again, a lot of our customers are telcos, and they came to us with this issue of, obviously 5G rollout's a big thing now, in-home 5Gs, they're trying to, look into that. And now the problem with 5G is it uses millimeter waves at very, very high frequencies, which is what enables it to deliver that speed. But the problem is, and by the way, excuse this extremely boring looking slide in the background. So the problem is it's very easily obstructed by vegetation, building materials, all these different kinds of things. To kind of visualize it, so say you're in Boston, it's winter, you stand in a spot and you look at your phone, you're getting 4 bars of 5G. Assuming no infrastructure changes were made, if you go back to that exact same place in summer, you would not have the same quality of signal. And that's solely because there are now leaves on the trees. So that shows just how much 5G is impacted by environmental factors, even, things just like leaves. So, there's this problem, and, obviously everyone's trying to do 5G rollouts, and, we kind of came across Omniverse, and we thought, hey, wouldn't it be cool if, we can solve this problem using this amazing software that allows us to, do this in a 3-dimensional way. So, you don't even have to, it's a simulation of the real world, but without you having to go and actually invest anything in physical infrastructure. And obviously this is just one use of digital twins, and one use of Omniverse. I'm sure everyone on these live streams has seen tons of cool stuff you can do, but we really want this to kind of serve as an inspiration of, digital twins in Omniverse, how they can not just be used for business, but for personal or for, open source projects. There's so much potential here, and we really hope to kind of demonstrate that today. I don't know if, anyone on the NVIDIA side, you guys want to mention anything about some digital twins, or?
No, I think that's good.
Yeah, it kind of covers it. So anyway, Brendan,
yeah. We're going to go ahead and give a demo and even dive into the code and stuff. But before we do that, just to get you prepared, we wanted to give a high-level overview of the major players here that allows this application to work. There's 4 main pieces, and I think the first question anybody should ask themselves when they want to go about creating a digital twin is how you're going to represent something in the real world digitally. And for this case, that means we need data. We need data about what the land looks like. We need data about what buildings are there, where radio towers are. So luckily, there's a lot of great open data sets out there, especially for the northern United States, that encompass a lot of this data. There's a LiDAR terrain scans. Airplanes fly overhead, and they take scans of the terrain, and they make it available online. And our database is well equipped to handle all of these points of data to create a digital twin of a city. Today, we're going to be talking about Seattle. The second main piece of this puzzle is Heavy.AI. This is our GPU accelerated database. Databases, traditionally are for storing and retrieving data. Something that's kind of unique and special for this use case that Heavy.AI allows for is custom table functions. So instead of moving your data out of the database and then processing it somewhere else, the database already runs on GPUs. So it's actually going to be the fastest to run these manipulations on the data where it lies, where it can be parallelized by all the GPUs. So we take these table functions, which are functions that can accept tables of data as input, as well as normal arguments, and then they output data in a format that's similar to tables. So you can actually query the results of these table functions like you would a table in a database, which is neat. The third major part of this is going to be Omniverse. Everybody here is, already a fan of Omniverse. I don't have to dig too deep to tell you what Omniverse is about, but what we use it for is going to be to display the results of our digital twin data. Sitting on top of Omniverse is an extension that we've made for it, which is what we call Heavy.AI, and this is the piece of our Kit application that is responsible for the user interface. And it's also responsible for authenticating with the database and making those calls and calling those table functions and taking the results of those table functions and translating them to USD primitives and materials and meshes and so on. But yeah, I think that about covers the big pieces of this. I'm excited to get in and show you what we've done.
So yeah, as mentioned before, as Maddie mentioned, one of the big things was, we originally developed this as an extension. What we really wanted was a standalone application. And so, I dug in and we did some research and we discovered the Kit SDK. And so we kind of ran with it. And again, big thanks to Maddie. He did help me with some of the questions I had initially, but it is awesome. We love the Kit SDK. We love what it has enabled us to do. So here we're gonna start up the application, and one really cool thing about Kit, which you'll see in a second as soon as I do this, is it's you can actually do these things called quick layouts. So you can go in here and you can either save a layout or load a layout, and it's just a JSON file. And it's basically, if you're familiar with, if you're used to doing things in Create, sometimes you have to drag windows around, or if you have a lot of windows, you'll notice they're all kind of stripped out. We just have the bare minimum, and it's all through this layout function here. So basically, it was as easy as dragging the windows where I want. I save a layout, and then programmatically, I load different. We load different layouts into the app. So the Kit SDK has been awesome. We're huge proponents of it, and anyone who has any questions, we're really happy to answer.
That's awesome.
Brendan, you want to go ahead and?
Yeah, so we're going to be generating a fresh scene here on the live, just to show you that we're creating this from scratch. So this is our menu item here that has some preset locations. We're going to be digging into Seattle today. And also we have a quick menu there to set the default attributes for the towers. When you run RF prop simulation, radio frequency simulations, you need to know certain information about those towers so that you can more realistically simulate the radio frequency and the signal strength across your map. Oh, wow, that was quick. I have a few more things to say about how we generate this map, though. So we have the terrain data set. It's LiDAR. And what we do is we chunk it into these tiles, and each tile is a square kilometer. And for each tile, we go through and we take a evenly distributed subset of these LiDAR points, and we create a point cloud of them. And a point cloud is just a 3D representation of data. So it's kind of like a pixel in 3D space. All these little tiny circles get composed together to create the terrain that you see in front of you, which is really neat. We also do take the same data and create a mesh out of it. We use the mesh for certain raycasting operations, but it's of lower resolution than the point cloud, and frankly, the point cloud just looks cooler. So we typically browse around on the point cloud side of things. After we've loaded the towers and run our first simulation, you can see all the yellow parts. Those are hotspots that are created by the radio towers and where they're located. We take that data and we do a neat little technical trick, like a performance tweak, and we actually create a texture of the coloring across the map, and we actually project it down from above on top of everything. So instead of going point by point and changing the color of it corresponding with what the signal strength is at that location, we have a single texture file that we project down onto it to apply the colors to the materials, which is pretty interesting. Oh man, that just looks so cool. There's so much detail. Chris, you want to show us some neat stuff?
Wild, wild, wild.
So for any football fans out there, you might recognize this. This is the Seattle Seahawks Stadium. And you can see how close we can get. This LiDAR data is up to 10 centimeters in precision. And I believe, correct me if I'm wrong, Brendan, but this entire scene, I'm not sure if it's expanded or normal scale, I think 50 billion points of LiDAR data.
It's definitely in the billion. I can't say exactly how many. And what's neat is that sampling process allows us to add more or less points depending on your GPU memory. So if you don't have as powerful a machine, you sample less. Those points will be a little bit further apart from each other. But if you have, the latest and greatest, crank up that sample percentage, and you'll get some very high resolution, crisp terrain showing. It's very neat.
So here's another, so you can see we've got a Ferris wheel right on the water there next to downtown. So yeah, here's the downtown. So this is actually just all LiDAR data right now. And what I'm about to do is I'm going to enable the building. So right now what we've done is these are actual USD prims. So we sit them on top of the LiDAR data, and this gives us actual physical USD objects within the scene. So the colors of the buildings are going to correspond again to the signal strength, same as the terrain you saw. So you can kind of see a legend down here that shows that. But now let's talk about towers, because this is, for a radio frequency prop. So this is my favorite tower, this guy over here, and I think this part's really cool. So we can just wait a second. So there you can see the effect. So this is a mode where you can just pick a single tower, and you can view the RF propagation from that tower. You can clearly see how the skyscrapers behind it instantly block the propagation, but over the water, there's nothing to block the signal, so it spreads out. So you can we can select a whole group of towers in here, and this is useful for telcos. They want to dig in and see what effect are these towers having? How are they affecting buildings around them? Things of that nature. Plus, it just looks really cool.
Yeah, it's amazing. I mean, you're recoloring all the 50 billion points or whatever on the fly, right?
Oh yeah,
that's
that neat trick that we have where we project the texture down. So we have like a 1-to-1 representation of just the flat texture file that gets projected down on everything.
Nice.
So you can play RF propagation gaming in your spare time. it just looks so fun and interactive.
Yeah, it's like SimCity. We have a limited budget. We can just add towers if we want. We can move them, change them.
Well, actually, let's play around right now. Let's do that. So up here, this is a mode that controls whether the propagation effect is from just the selected towers or all the towers. So we're going to change it to all the towers, and let's play a little game. So you can see over here, we've got a big dead zone. Not much going on here, not much 5G signals. So let's light them up a little bit. Let's give them some signal. So this is our add tower mode. Brendan, do you want to talk about this? Because this is kind of...
Yeah. What we do is we overlay a frame on the viewport that has a click handler, and we take the mouse coordinates of the click on that frame. We convert it to NDC, the normalized device coordinates, and then we cast a ray out that hits the base mesh underneath of the point cloud, and we then know where you've clicked, and we can add a tower prim to the scene that is automatically picked up by event listeners with our abstract manipulator model, and we automatically rerun the simulation so that shortly after you add new towers, you can see the effect of them in near real time. It's so cool.
And if I had a better GPU, this would be a million times faster. I'm on an 8 gig 3070, so I don't know if NVIDIA team's giving out Christmas presents, but
I think something went on sale today. I'm not sure what it was.
Oh, okay.
Card.
It went, and it came, and it went.
It went very, very quickly.
Those towers are looking a little short, Chris. You should bump those up a bit.
Yeah, let's do that. But as you can see, we had a dead zone there, and we added some towers, and now it's no longer dead. So, but there's a lot more fun stuff we can do. So besides adding towers, we can actually edit the attributes on towers. We'll demo how we did this later because this is a really cool widget. Let's do something fun like make this guy 100 meters tall. So in a second, you can instantly see the effect that had on the RF propagation, but also you can see he's literally 100 meters tall. You compare those two guys right there. You can do other things.
That with the HOA.
Yeah, we can jack up the power on him, and do all these kind of things. Obviously it's fun, but in a real world scenario, maybe you just don't want to. It's expensive to sit there and build a new tower, so maybe it's cheaper to modify existing infrastructure, things like that. But now let's do something really crazy. So if we really wanted, let's kill all the service to downtown Seattle and
No.
You sound like a villain.
have Starbucks employees are getting yelled at by their customers. Give it a second. Hopefully it doesn't crash. Computer.
We're doing it live.
Yeah, we're doing it live.
Did you hide them or delete them?
I deleted them, supposedly.
Hiding them might have picked it up. I don't know that we actually listened to the towers being removed that way.
Yeah,
we have a couple custom event listeners that we subscribe to for some things.
Well, it should have killed the signal.
Yeah, it would have been blackout. There's a couple of UI stuff that we could talk about here. As we transition toward how we did this.
Yeah, one thing I did want to highlight is you guys have probably noticed, and I know Matthias mentioned, is that we went ahead and built our own UI for this. So obviously, Omniverse comes with tons of custom widgets, which were the inspiration for a lot of these. But we kind of, we wanted to kind of put our own stamp on it and make it unique. So all the, UI controls you see here, we built. And we'll show you how we did that later. One thing we kind of came up with, Brendan came up with, was a component system.
Before we dig into that, I just wanted to kind of talk about what the pieces of the UI on the screen are actually doing. Would you mind selecting a tower?
Yeah, absolutely. So let's grab this guy here.
Cool. So we have popovers. So when you select towers, we kind of aggregate information about those towers and display them above the tower. A newer feature we're doing is trying to determine which buildings are receiving service from those towers. So underneath you see that we've calculated that this one tower is actually providing service to 35 buildings.
Nice.
On the right side of the screen, we have what we refer to as our info panel, and this is kind of like the mother load. This is the main component. It's responsible for doing quite a lot. If you notice, when he hovers over that panel, it actually shows a label underneath of it. So if you had multiple towers selected, you hover over that panel, and we can show a highlight of which tower we're receiving, which tower's attributes that we're taking a look at, and it switches between those. We also have metrics, and that tower, the selected towers panel, is kind of this. It's a similar aggregate panel as the popover, but that one actually allows you to edit the attributes of multiple towers at a time. So if you know that you need to change the power or the height of all the towers that are in a particular area for who knows what business reason. We're not talking about business reasons today. We're just doing fun stuff. But yeah, so we had 10 towers there, and we just instantly updated the height of all of them to 60, and it updated and resimmed in real time, which is pretty neat.
Wow.
Across the top, we have kind of our action bar over there. The very top. So we can change the color map if there's anything interfering with the colors. You can change it from that purple to yellow to the red to green. Some of the early feedback that we got is that when you lasso to select a bunch of things in the screen at one time, we were selecting both buildings and towers, which was very confusing because as soon as you start dragging those towers around, suddenly you're in SimCity God mode and you're moving buildings everywhere, and that's usually, for most companies, that's not something that's within their power to do. So we have this selection mode. It's that drop down at the top left where you can actually specify, like, am I interested in buildings? And we do have information about the buildings, whether it's commercial or residential, the estimated occupancy, the footprint and square footage. And then in that mode, we make all of the building prims are pickable, and we make everything else unpickable. And then when you switch from the buildings to the towers mode, we do the vice versa. We take all the building prims, make them unpickable, and now you can only select towers, which just made for an easier and less frustrating user experience. Chris, is there anything that you wanted to highlight in our UI?
We've got these info panels over here. One thing, kind of a recent thing we did was the ability to search through these panels. So maybe I want to see all the buildings that are on. There's a street called Airport Street in Seattle, and I'm not sure what's. Oh my gosh! Sorry, that live demos.
It wouldn't be a dev talk without some UI jankiness.
Okay, well, I've messed with this scene a little too much. We'll dive into this later. I'll generate a fresh scene.
It's really cool how it works, so we're excited to share the innards of that with you.
Yeah.
Let me ask you. So you have so much great customization stuff going on here. How did your team go about like learning how to do all this? Did you rely on your own exploration? Did you rely on videos or documentation? What was the most helpful?
The Omni UI documentation was pretty good, especially the version of the documentation that you open when you open not create but code. When you open code, there's a bunch of tabs that are already open that really provide a great overview and code samples for how to accomplish a lot of different things within not just Omni UI but Omni Scene, which we also take advantage of. That's been my favorite. Chris, what would you say is yours?
I actually have used the online docs a little bit more, but kind of when we started pushing into these real custom things, it's been grepping through the Omniverse source and finding examples, or actual source code for custom widgets that have already been built, and then just reading through the source. I'll just pull the source code in. I've done this several times into our repo, seeing how it works, debugging it, and then trying to replicate it.
That's great. Yeah, we've heard a lot from a lot of users too how valuable that is. That's awesome. Thank you.
Yeah, I will say from the Omniverse side, we've been very impressed with the Heavy.AI's UI. You guys get brought up internally a lot. I mean, you see the cool UI that they made on top of this? Like it's very well stylized and all that stuff. Yeah. Very pretty.
We're actually about to dive into what we've made that enables us to do that. So thank you for the great compliment there.
And shout out to our wonderful UX and UI designer, Travis Simpson. I'm not sure if he's listening in, but he really conceptualized all that, and
it would not be as pretty without him.
Yeah, so trust us. You don't want us designing things from scratch. But so next Brendan will talk about this component system, which is really the backbone of how we build all these custom UI elements.
Cool, thanks. Since we were talking about UI, it makes sense to start jumping into what we did that allows us to make what we made. And usually I like to go off the cuff, but for this, there's a lot to cover. So I have some notes that I'll be looking through. We did take full advantage of the styling that Omni UI provides. It's very style sheet based. If you have like a web development background, like Chris and I both do, that was very comfortable to learn and adapt to.
CSS, you know how to style. I'm sorry to jump in. If you know CSS, that's it. You know how it works. It's super easy. So we love that.
No excuses for just stock widgets. You can make it look as cool as you want to. Make your app your own. That's what the Omniverse Kit app is about. You are packaging your extensions to make it look and behave exactly how you want to, and there's no concessions you should be making there. So one of the neatest things that we've done for our Kit app is this component system. Component is a base class that we created to subclass for each of our individual UI elements, and this provided us with a lot of key benefits that allowed us to make what we made. We kind of used, coming from a web development background, we did use kind of React for inspiration for this. We wanted to standardize the creation of new components, and we wanted to standardize the way that they interact with each other and become composable. So what this component system allows for is modularity first and foremost. When you have a component, you want it to be dedicated to a single purpose. This is kind of like the Unix philosophy. A component does something very specific, and it does it very well, and it's designed to be composable and interact easily within a system of other components. The code snippet that we have on the slide here is like a great representation of a simple component. The name represents what it does. It's a click counter. It counts clicks. And the type annotations, these are Python type annotations, they indicate how you will interact with it and compose it within a system of other components. If you needed to add a change handler to run code in the parent component, you can optionally pass an on-change handler that will be called whenever that button is pressed, and it's going to be passed the new value of the click every time that you click it. Another nice feature of this is that it's self-documenting in a way. If you attempt to pass a property to a component that hasn't been annotated, you'll get an error. And when you have multiple developers working on the same project, you're going to want a degree of self-documentation so that if somebody comes in after you to make a tweak or a change, it should become pretty clear very quickly how you're supposed to interact with this component. So that's like a huge, nice quality of life feature for long-term management of a complicated UI system. Yeah, you have to specify the name and the type of each of the properties. Otherwise, you won't be able to use it. Kind of the last two things that I'm really the most excited about. The first of which is the ability to render something in place. We ran into a roadblock where we needed to selectively update UI elements without updating everything around it. We do some process like in computationally expensive things, and we need to selectively re-render certain things. So for an example out of Omni UI, if you had an Omni UI label and you wanted to update it in place, well, that's easy. You save a reference to it, and then using that reference, you can set the text of the label to be something else, and it updates in real time. Our component system allows us to also selectively re-render more complicated components that aren't just like a single string value. And that also allows us to selectively choose when we want to re-render things. This is really like the core of what allows for some of the more complicated behaviors and makes the maintenance, eliminate some of the maintenance overhead that would normally come if we didn't have like a standard in place for this. The last thing though that I want to mention about the component system is that taking inspiration from React, it actually can be reactive. It can change and re-render based off of changes in the scene, changes in abstract manipulator models, changes to the stage. So a component can become responsible for updating itself by listening to the scene and all these different ways that it can respond and view the data that you have in Omniverse. And that keeps your UI always up to date so that you don't have to continuously code all these different edge cases and things. Chris, I think that's about a great overview. Is there anything you think I might have left out here?
One big thing. So we will actually be publishing this base class as an extension after our talk. So if you're interested in utilizing this or trying it out, and maybe it, this just happened to work for us. If hopefully maybe if it'll work for you too, feel free to pull it as an extension and check it out. And we'll both be on Discord. I'm on there every day, so feel free to ask us any questions if you decide to utilize it.
That's awesome. What channel? What channel do you hang out on?
Just the Omniverse channel. I'm usually like in the Kit app because I'm super big into Kit.
Okay, cool.
But yeah, I'm kind of all over the place. So yeah, Kit app or developing extensions, developing apps. Those three I kind of check into.
All right, cool. Well, you're definitely building a fan base here on the chat. Everyone's really impressed by what they're seeing, and it's so great that you guys are going through and explaining everything and releasing everything for the public for people to be able to mess around with it, and that's great. So thank you.
Absolutely. Is there any questions so far?
Chat's going wild. Simon, I think, has been doing a really great job covering the chat.
Oh, that's awesome. Shout out to Simon.
Thank you, Simon. Yes, Simon, by the way, everyone, he is the mad genius behind all the back end, all the rendering, all that. That's all his work. He's
translating the results of HeavyDB and actually showing something and rendering it 3D in the viewport. It's all Simon. He can't get enough credit for it.
He is an absolute one-man powerhouse. This would not look anything like it does without him and his work. So yeah, huge shout out.
You guys have a great team. Amazing.
We really do. And it's a small team, and we haven't, there's been several months of work, but it kind of shows how quickly you can get up and going in Omniverse. If you have even just a few people dedicated to doing something, you can really make something huge really quickly. So.
Cool. I really like this component system. I think it's cool that Kit SDK didn't really tie your hands. You took the building blocks and built something that worked for you to then develop something bigger. So developer tools and libraries really excite me. So it's cool to see this, and I think everybody should play with it. You guys, you modeled it after React. I'm guessing you have more JavaScript experience. Did you have any Python experience coming into this?
I did. I recently got my master's degree in data science, and all of my classes use Python as their primary language. So I had a fair bit of experience going into that, but I hadn't worked professionally with Python before. So when I was asked to start working on this, I really had to draw from my web development experience and apply what I knew from that to Python. So, your mileage may vary with this component system, but we've adopted it and it's worked really well for us.
Yeah, I had I actually worked on a native GUI library as an open source project for a couple years. But yeah, I didn't have really any Python experience. I was all like C, and then obviously the web stuff. So
cool. All right, you guys had. Did you guys have code to show, or what's next?
Yeah, we can go as deep or shallow as I guess as anybody is willing to go.
Yeah,
we'll get it going side by side so that we can show the code and then also show what it ends up being in the user interface.
Sounds good.
So we're gonna just get this set up real quick. And again, if anyone has questions, feel free to interrupt us. We've been staring at this code for so long, we kind of hopefully don't go through it too quickly, but feel free to stop us. Hey, let me turn base.
Just for like the high level overview of the code base, we use abstract manipulator models for dealing with all of the buildings and all the towers. The buildings have their own abstract manipulator model, and did I say towers or buildings? The other one also has an abstract manipulator model. And what's nice about those is you have your centralized place where you'll actually be selecting them and applying attributes to all of them. But it's also a great place where you can emit these item changed events that you can listen to from anywhere in your application. So if we have a UI element that needs to update based off of a building or a tower changing, we just pass it that model, and when it inits, we go ahead and subscribe to the items and we listen for the ones that we care about, and then we can re-render the UI component as those items change. Two other big pieces is, so we have the manipulator models that deal with all of the towers and all of the buildings, but we also have singular tower classes and building classes, which represent a single one. So they're tied to a prim. They read attributes off from the prim vars, and they also are responsible for the actual manipulating of individual prims. So highly specific UI elements can even listen to the stage, but you bring the scope in to where you're only listening to the path of the tower or the building that you care about. And that allows you to do highly specific subscriptions to re-render your components based off of things that happen in your scene.
So here's an example. We can just show the tower class real quick. Here's the tower class. You can see, like, for the name, for example, we're pulling it off. The path gets actually passed in here. So this example, where do we have something here? Here we go. Here's where we're reading an attribute off the prim for the frequency. And we're doing this because, as you can see, or as you saw, that this can be adjusted. So this base class will then go ahead and read the attribute right off the prim. That's
we use getters and setters that way. So a getter on these tower and building classes just goes straight to the prime var to read the current value there. And we also have setters so that you interact with the class that represents the tower or a building, but it's actually getting written to the prim var.
Cool.
Yeah. So we'll start with Brendan. What do you want to start with? Let's pick out a few elements and do some.
Yeah, that right sidebar is just such a beast of very, very cool. A lot of interactions happening over there. I'm particularly fond of the infinite scrolling frame.
Yeah, let's start.
Yeah, let's. So, if you don't have anything selected, we want this info panel to show you everything. You should be able to filter through it and find the towers that you care about, and eventually select those towers because you've determined that's the set of towers that you're interested in. But if there's hundreds or thousands of these towers, we don't want to render every component. So the obvious and tried and true solution for this is to have infinite scrolling. So as that scroll bar gets down towards the bottom, it reaches a certain threshold where we go ahead and we load the next page size worth of these panels. And the further down you scroll, the more and more of these that we load. And, it ends up being fairly performant to have all of those panels there. We've never had out of memory crashes or anything like that. But, we were able to accomplish it in under 100 lines of code using Omni UI and our component system. So that just felt like a really neat it didn't feel like work. I was like, oh, this is so cool.
Yeah.
So like we said with the component system, the Python annotations describe how you should be interacting with it. So there's really only two things that you need to supply to this. Everything else has default values. So, you can provide default values for things that you don't need to tweak. And then if you do need, you have these knobs that you can tune for fine-tune adjustments. So infinite scrolling frame is a component that takes a property items that can be a list of anything that you want to show in a scrolling frame. And then it also takes a function that you can call that gets provided one of these items and returns a component. So when we have this scrolling frame, if we could go down to, render page is good. So we can see that, render page, so there's a little bit of behind the scenes stuff that we haven't explained about the component system, but in general, it saves a reference to a container that holds everything that's inside of it. So when you render it, you have a reference to a container in the render tree at the location where it was called and initted and rendered. But everything that gets added to it under the render method is underneath of that container. So anytime you need to re-render, that container gets cleared out and then you re-render it, which updates it. So for this, when we need to render a new page of items, if we could scroll up to render page, you can see that we are calling self.renderItem, which is that function that we provided it as a property, and we're feeding it the current item that needs to be rendered on the page. And then we append those to a list of item components just in case we need to safely handle and destroy them. But as you scroll down, it'll load the next page. It keeps track internally using an internal state of which page you're on and how many items you want to show per page, and how far from the bottom of the screen that you want to be before we show the next, before we render the next 10 items. And it just, it felt like a very nice showcase of some of the more complicated things that we were able to do with Omni UI. So I'm pretty proud of that.
Awesome.
And I guess one kind of quick thing, I was trying to find a small thing just to kind of give you guys a better visual of the component system, one that's not too complicated. Signal Legend might be a good one. So, obviously you subclass component, Brendan talked about, you provide the props for it. You actually, what's cool is you don't need an init method if you're just assigning the past keyword args as keyword args. So here we're obviously doing other things. But if we didn't need to do anything else, if we just needed to pass it these two props and it needed to assign those as keyword args, you don't even need to include the init function because this component class already does that for you. So that's one really cool thing. So basically when you're creating a component, the base thing you need is if you need any supplied props, and then you just need a render method. And then, the render method is called when you just, so if we did Signal Legend, prop 1 equals 1, prop 2 equals 2. As soon as you call that, it's going to automatically call the render method. Do you want
overrideable though? There are some advanced cases where you don't need it to render right away. So there is a keyword that you can pass like render on init false, and then that allows you to get more into advanced use cases once you understand the limitations of the components, it allows you to sidestep some of those things. But it's still kind of a work in progress. But it's fairly flexible.
And then the other thing is you pass a destroy method, and then that'll obviously just anything you need to destroy within the component. When you call that, I have seen that in a lot of some of the Omni UI widget examples. So it's kind of drawn inspiration from that.
Yep.
Yeah, so there it would be unsubscribing from subscriptions, and those subscriptions were actually created in the init. So you render your component, it sets up all the subscriptions it needs in order to update itself, and then whenever you're done, you call destroy to clean it up properly and not have to worry about it.
But without the subscriptions, you wouldn't even need to provide a destroy method because, again, that's right, Brennan, right? Because that's provided by the base.
Yep. There's a default implementation for it, but anything specific you do in your subclass, you'll need to call that in order to properly do the cleanup.
So,
okay. Is somebody about to ask something? I think we might have cut somebody off. No?
I think we're good.
Cool.
Okay.
So
that was infinite scrolling frame. I'll talk about the panels real quick. So this was kind of an interesting one. So obviously I have info panels here. And so the problem came in, maybe clients want to bring their own data. So maybe this data is useful for one client, but another client has some additional attributes about, the buildings or the towers they want to provide. So what we did is we set up a config file, and this allows you to configure all your settings for the application. So there's a base config, and then you can overwrite anything in your own local config. So we built this building data column, so it's just a simple array of objects. And then so you can actually go in here and specify, hey, here's all the columns in my table that I care about. And then what happens is when you load a scene, it reads this config file, uses it to build the select, and then pulls in all the data. So, the queries basically become customizable just through this JSON configuration file. So that's kind of the first part about it is, but then, then there's another problem of, so I think we have 20,000 plus buildings in this data set. And, how do you deal with that data, especially when we get into things like searching through it? At first, we tried stashing the data on prims, but we found out reading through 20,000 prims was not a very performant, as you can probably imagine. So what we do is when a scene loads, you builds the customized query and then stores it in a pandas data frame. And then so anything that needs to be search or display information, it actually just goes and looks it up in the data frame and then uses that to display all these results you see here. And obviously pandas is extremely fast, extremely performant. But what's really cool is, obviously you've seen that, you can go ahead and modify tower attributes and stuff. So if on the load, you're constantly pulling in, if you're constantly rebuilding the data frame from the database, you're going to lose these customizable attributes. So what's really cool is we stash it on Nucleus. And then every time we load, if there's a data frame on Nucleus, we just go ahead and load that. So it was really, really handy. And, we've kind of talked about how we use Nucleus, for example, when you do the RF prop simulations, we're just updating texture files, and then Nucleus says, hey, this texture file has been updated. So we've really taken advantage of some of the stuff Nucleus offers. That's kind of how we're able to get all this data in and read it all so quickly.
Yep.
Nucleus, actually. Sorry,
No,
Brandon. I was going to ask, just on the subject of Nucleus, how did you guys leverage the collaboration functionality in terms of the developers working simultaneously? Did you guys use that a lot?
We had, it's something that we kept in mind while we were working on it. It was one of those features that we didn't want to bake in too early because we needed to get to a proof of concept and kind of sprint ahead towards the use case that we wanted to hit. But we have been thinking of how we would do this. We would have somebody driving, somebody would actually be connected to HeavyDB making the queries, and other people would be in there and manipulating the prims and in the planning, just to get into the business side of it a little bit, when you're planning these sites, you'll have different scenarios. And the scenario is like, will that company lease us their rooftop so that we can put a radio tower on it? That might be scenario A. That's our ideal situation. We put a radio tower here. It covers all of this stuff. And then we might have other scenarios as fallback plans. So Nucleus, we would like to be able to manage these different scenarios so that one person is driving and creating all of them, but other people can go in and open any of these scenarios within Nucleus, and they would be able to view, all these different scenarios for different business use cases. That's about as far as we've thought about it. We haven't coded ourselves into a corner. We should still be able to implement that. But yeah, it's something I was excited about very early on, but I had to put up my horse blinders and okay, focus on what we're working on, because there's too many fancy, fun, shiny things to go around and play with.
That makes total sense. Wow, thanks for explaining.
So, I keep telling people that developing for Omniverse is fun, and you guys said it as well. Is there something that you really liked about it? What was your favorite thing as a developer about developing for Omniverse?
It's new.
It is new. I guess some of my favorite things. I really like the flexibility of the UI library. I love that, if you know CSS, you can style things instantly. I like how, like I mentioned before, you can just pull in source and kind of, the debugging has been awesome. Brendan's in 1960 and refuses to use a debugger, but I love
console logs all the way, print statements every 5 lines. I will figure out that problem.
But yeah, it's just the flexibility of it. You're given this kind of base framework, but if you really dig into it, there's just with the subscriptions and there's even some of the workarounds I was going to show in a minute. Matthias helped me with. If you get into weird things where you need to use carb for things, it's just you never really paint yourself into a corner too much. There's always so many ways to approach things, and even the component system, ways you can just kind of build your own thing on top of it. And I think the deeper you dive into it, the more you realize how much is in there, even though it's so new. How many usually new frameworks I find are more limiting, but I haven't really found that yet. So that would be my answer.
Yeah, so Omniverse is this platform for building and operating metaverse applications. So the way that it's been built to be so modular, and then you can just plug in the blocks that you need in order to do what you need. I think that's one of its superpowers, I think, for development. So yeah, I just keep telling people, you got to try it.
There's a lot of aha moments. As an engineer, I'm driven by here's the problem, and then what is it? And then it's I know. And the aha moments are we can use event listeners for that. There's just so many tools at your disposal. We probably could have solved this problem a few other ways. We're very happy with what we've come up with, but it's just a lot of, it's easiest to say. It's a lot of fun to develop on Omniverse.
It is. It's fun to work with. Python's, I think, well known for its simplicity. And so you're not really beleaguered by the language itself, and you kind of get into a zone when you're working on it for 6 hours one day, where you're just you get super creative, kind of you're a painter, and you're just whoa, I could probably make this do this, and then it works, and in 2 lines of code, and you're wow, I can't believe that actually worked.
And then it's the match made in heaven is that it's fun to work with for developers, and then it also solves the problem, which is the business side. The folks on the business side are happy as well, I'm sure. Cool. So I can't say this enough. I think you guys have a great application. It's really nice to look at. I like the that you guys were able to do your branding and make it look like your own. So thank you guys for showing us behind the scenes and some of the secret sauce that you guys had going on there. It's been a pleasure to have you guys here.
Thank you so much. This was a lot of fun.
Yeah, thank you so much for having us. And yeah, like I said, we're on Discord. If anyone has any questions, we'll be releasing the component system. Anything curious about how we did, pick our brains, or you've got some things we could improve upon. We'd love to hear them too. The community is one of the best parts. I want to give a shout out to Dane and his team for they've been a big support for us the whole way. Maddie is, I was joking earlier, me and him have become good friends. Come across some problems and he's always helped me, and just the entire community, even people from the community answering things. So, we want to give back as much as possible and be as engaged as possible. And we just love to, hear ideas, suggestions, help where we can, to learn where we can.
You guys are awesome. Very fun. Okay, so let's do this. Let's bring the party over to Discord. We can hang out in the community voice chat room. Anyone who's watching the stream, come on over. Discord.gg/NVIDIA Omniverse, very easy to remember. We'll head over there now. You could turn on your webcam if you like, or you can just use the little chat to ask your question. And Brandon and Chris have offered to hang out for a while there. So thanks everybody for tuning in. Thanks for all these great questions. Thanks to the Heavy AI team, of course, Chris, Brendan, but also thanks to Simon, who's been a beast on the chat. Very impressive, great answers. I've been watching his posts. Thanks everybody watching. Thanks Dane for joining us, and Maddie and Wendy. Feel better. Thank you for managing everything behind the scenes. You did a great job as always. Queen of the stream. We'll be back next week for Replicator. So that'll be a really good one also. So thank you everybody.
Thanks. See you soon.